explain the cell. The cell is the basic structural and functional unit of all living beings. They possess the ability to replicate. The basic structural features are the cell membrane, the cytoplasm, and the genetic material. Cell types are the prokaryotic, are found only in bacteria and archaea. The eukaryotics are formed of the structure of proteins, fungi, plants, and animals. The difference of the prokaryotic and the eukaryotic is that the eukaryotic has a nucleus. The cell wall. The cell wall protects the plasma membrane and helps maintain the cell shape. The cell membrane is a liquid bilayer with proteins immersed. The nucleus houses the DNA in its interior and consists of three main parts. The first one is the nuclear envelope, which is a membrane formed by two lipid layers. The second one is the chromatin. It has the ability to be colored by the colors used to observe it under the light microscope. The third one is the nucleolus. Is the site of ribosome manufacture. The cytoplasm is the space between the hereditary material and the plasma membrane. Organelles with membranes are the endoplasmic reticulum, the rough endoplasmic reticulum, and the smooth endoplasmic reticulum. Organelles without membranes are the ribosome, the cytoskeleton, and the centrioles. And that's all.
Hi, so now I will explain the characteristics of living things and difference between prokaryotic and eukaryotic cells. To begin with, how do you differentiate a living being from a dead being? Many people will think things like they're different because living things move, but no, there are so many specifically characteristics to differentiate them, and they are the following. Number 1. Living beings are made of one or more cells. Number 2, they have metabolism. Number 3, they maintain homeostasis. Number 4, they respond to stimuli. Number 5, they have DNA as their genetic material. Number 6, they grow. Number 7, they can reproduce. And number 8, they evolve, so they can form populations. Now, going back to point number 1, there are two types of cells. Eukaryotic and prokaryotic cells are the two types of cells that differ primarily in their size, structure, and the presence of certain organelles. Eukaryotic cells are larger and have a defined nucleus that contains the genetic material, along with other organelles such as mitochondria and the endoplasmic reticulum. In contrast, prokaryotic cells are smaller, lack a nucleus, and their genetic material is dispersed within the cytoplasm. In terms of shape, prokaryotic cells are typically rod-shaped and spiral, while eukaryotic cells have more varied forms.
Now I'm going to explain the history of the microscope, the cell, and the cell theory. The history of biology is deeply connected to the development of the microscope. In the late 16th century, in 1590, Dutch lens makers Hahn and Zacharias Hansen built the first compound microscope, a simple device that allowed the first observation of tiny structures. In 1665, the English scientist Robert Hooke used an improved microscope to observe a thin slice of cork. He noticed that small cavities that he called cells, a term we still use today. Shortly after, Dutch-American Anton van Leeuwenhoek, with no formal scientific training, developed high-quality single-lens microscope. He was the first to observe bacteria and protozoa, which he called animalcules. His detailed observations laid the foundation for microbiology. In the 19th century, German scientists Matthias Schleiden and Theodor Swan proposed cell theory, stating that all living organisms are made of cells. and that the cell is the basic unit of life. Later, Rudolf Virchow added that all cells come from pre-existing cells, disproving the idea of spontaneous generation. These discoveries helps us to understanding that cells are the structural and functional units of all living beings, from simple bacteria to humans. Cell theory is fundamental in biology and medicine, explaining how organisms develop, function, and how diseases arise and progress. Today, thanks to advances in microscopy, we can study cells in unprecedented detail, revolutionizing our understanding of life at the molecular level.
Levels of organization. All bodily functions rely on a coordinating system, performing different tasks simultaneously. The most important thing is organization. Where will you start if you were tasked with organizing the human body? Well, if we point to the levels that make up life, we could start with a submicroscopic level such as the atom. A set of atoms, properly intertwined, will form a molecule. The molecules will form organelles that will be integrated to build parts of a cell. A group of tens of billions of cells with similar functions and structures performing a particular task is known as a tissue. Tissues are building blocks for organs. A group of organs comprise a system such as digestive, respiratory, urinary, skeletal, muscular, and others. There are 4 basic animal tissue types: connective, epithelial, muscle, and nerve. Connective tissue supports other tissues and binds them together like bone, blood, and lymphatic tissues. Epithelial tissue provides a covering like skin. Muscle tissue includes straight muscles that move the skeleton and soft muscles such as muscles that surround stomach. Nerve tissue is made up of nerve cells and used to carry message to and from various parts of the body. Homeostasis is the ability of living things to maintain their internal conditions despite the conditions of the external environment. The body maintains homeostasis by controlling a host of variables ranging from body temperature, blood pH, glucose levels, to fluid balance, sodium, potassium, and calcium ion concentrations. At the beginning of the 19th century, it was debated whether microorganisms cause all illness or whether they were a natural reaction of the body to change its external environment. It was not until 1929 that physiologist Walter Cannon named homeostasis the action of these regulatory mechanisms. Cannon proposed that every physiological variable should have a homeostat.
Pregnancy, obesity, and addictions. In pregnancy, most of the mothers face 2 complications like preeclampsia and eclampsia. Preeclampsia is a complication that increases the blood pressure and affects directly to the lungs, brain, kidneys, and heart. And eclampsia is a damage that is a complication of preeclampsia that occurs during labor and can lead to a neurological damage. And another complication is obstetric hemorrhage that occurs an excessive uterine bleeding caused by underdevelopment of female reproductive tract, and is one of the most common causes of death during childbirth. And in addition, like social media, drugs, and processed food overstimulate the brain reward system, creating dependence, and over time, natural dopamine production decreases, making quitting harder. But addiction is a brain disorder, not just a lack of willpower.
In obesity, the gut called second brain produces 90% of serotonin, which affects moods. High sugar and high fat food brings temporary pressure but can cause long anxiety and irritability. And that's because healthy eating supports both like physical and mental well-being.